So first, a few words about ourselves. So I'm a Flutter dev at LeanCode with over 5 years of experience. I often work remotely from my camper van and just holding the best office use across Europe. And I'm a big dog person. So please come.
Here am I. Yes, hi everyone. I'm Kamil. I love video games, I love cats and clean code. And I care not only what is done, but also how it is done. And first, I would like you to imagine how it is to chase behind a big speeding car. And that's exactly the same feeling how it is to introduce new changes into big projects with large code base and many teams. And today we will talk about how we introduce powerful code assistant and automated all refactoring in one of these type of projects.
So about the agenda, we'll give you some context about the project and the strategy we took for the refactor. We're going to talk about custom links and codemod package, where we're going to jump straight into the implementation and show you actual code examples. And then we'll share how we ensured nothing broke with all these changes. And at the end, we'll give you some useful and practical tips how we can refactor things in your own projects. So if you'll have any questions, we'll be happy to answer them at the end of the talk.
So before we continue, we would like to make a little disclaimer here. Eating a hamburger like this is fun, but nothing special. With this burger, you would struggle just to take a bite and probably end up with your shirt covered in sauce and veggies. And honestly, seeing this burger would be pretty intimidating for most of us, and me personally, I would consider giving up at this point. So we're not here to deny the challenge of this task. The big burger is still a big burger. We want to show you an effective approach on how to take a bite out of this burger and start refactoring those big projects, and give you helpful tools to do it, like a fork. Fork is always there for big burgers.
Yes, so just to give you some context before we dive into the technical details, we're working together on the same project. We are migrating native apps to one Flutter app. It's a banking app, and there are about 100 mobile developers working on it in parallel. So we're split into squads, and each squad is responsible for other part of the app. We're a part of a platform team, so that means beyond handling some business features, we also have to take care of engineering excellence work, so things like Flutter upgrades, some code quality improvements, or just making the code and whole code base maintainable. And so now, as you can imagine, and the whole code base is huge. So if anyone has ever worked on a project, like banking project before, you know what it means. Tons of features that most users probably will never touch, but we still need to build, test, and ship them. So from an architecture perspective, we're working with fully repository setup. That means that we have around 50 packages, and things like payments, like it's all like features packages. And also we have common utils package, some design system package. So we fetch them all into the main project with dependencies. And the tricky part is whenever someone merges something into one of this repo, we can easily break the main project and blocks everyone else's work. So on top of that, many of our developers come from native iOS or Android backgrounds, so that means not everyone is fully up to speed with the latest Dart features or know how Flutter should be structured to keep a high performance and good code quality. And we do have design system, but it hasn't been ideal in practice. So we want to keep all of the components in this one repository, but we didn't have any tool to enforce it. So we saw violations in the code, people just using standard Flutter widget instead of our design system components. And when we joined the project and noticed all of this, we wanted to improve the developer experience and just make the code base more maintainable. And especially in such large projects with many repositories, many developers, it's quite a challenge. And it's also hard to make a change because we need approvals from leaders, they have little time, and we have to have this time freed up to work on such cases instead of our business features that should be delivered anyway. And just the whole process takes time, it's corporate work. So Kamil will show you the strategy that we came up with to improve the code despite all these obstacles at such a scale.
Okay, so we were given a very specific instructions. First, the development was still very focused on delivering business features, and those remained an absolute priority. Therefore, we couldn't afford to interrupt other developers' work and slow down the overall team efficiency. We were also asked to not introduce any regressions, which basically means we couldn't break anything what is already shipped, which is obvious. And last but not least, our changes had to be meaningful. They had to make a difference, and they had to result in clear benefits for overall project development. And I like to say that clean code is a subjective thing, but I believe that everyone can recognize a bad code smells. And with these challenging requirements, we had to figure out on how do we take a bite out of this big burger. So we came up with this roadmap, and first we decided to tackle issues of the new code that was continuously being created with bad smells as we spoke. Then we thought about broader cleanup and thought about how can we automate it because of its scale. And as Aga mentioned, it was a very big project. And finally, we decided to roll out these changes in small bites, which basically means many small PRs instead of huge ones, because otherwise people would be simply too afraid to review it. In the end, we got the results we hoped for. We achieved code consistency across the entire code base. Future code had fewer bugs, and also the developers reported to us that they can code faster because of the linking code assistance we introduced, and they get less negative comments on PR reviews because most of the common issues are already catched by this code assistance. And so let's get to the very beginning, to the very first step, tackling the issues of the new code. Like we said, starting cleanup wasn't enough because we couldn't outpace 100 developers. And custom lints were an answer to this problem. Custom lint is a Dart package available on pub.dev, but it is very similar to Dart Analyzer plugin, but actually allows you to write your own lint rules and quick fixes. And it will be easiest to explain this with an example. In this case, we had to address the issue of developers using material components instead of those from our design system. And we implemented a simple lint rule that was supposed to detect such cases, display a warning, and suggest a proper replacement from the design system. And as you can see in this example, it suggested the usage of app text widget instead of the text widget from material library. In another case, we had to deal with developers using magic numbers while building layouts with padding and spacings. And in this case, it also finds such cases and displays warning, suggests replacement. But now it also offers a quick fix, as you can see on the right side, which means that this issue can be fixed with a simple keyboard shortcut without even reading the warning message, which I don't advise, but it is possible with this tool. And because of that, it was very convenient for both of us, for both refactoring team and the development team, because there was no need for large training sessions for 100 developers, and Dart Analyzer was both teacher and assistant in this task. But what are custom lints and how do they work? They base on AST nodes, not just raw file contents, which means they understand Dart, they know what Dart's syntax is, and it allows for much smarter checks. They require very low effort in comparison to the high impact they can have on your code base. And let's take a look at this example. Let's code it together. Let's write a lint that forces adding an empty line after constructor, because we believe that it gives the class code much cleaner look. First, we have to start with writing a Dart lint_rule class and write a constructor for it. And if you take a look at this constructor, you may already see that it basically mirrors the warning message and the developer will see in the Visual Studio Code. Then you have to override run method, which is responsible for detecting such cases. And it's rather short, as you can see. All it takes to write a lint is register a constructor declaration listener into custom lint registry. And from here, you can access whole class declaration via parent node of the constructor. And you can check if there is an empty line between the constructor and the next member. That's basically it. If you want to also write a quick fix for it, you have to write a Dart fix class with a simple change builder. All of its code is visible here. It's very simple. And at the end of the day, you also have to inject your Dart fix class into Dart lint_rule class. And that's basically it. We injected our linting client into all the repositories of this project via the dependencies as Flutter package and analysis options. And as you can see, analysis options file in this project is basically empty. It contains only one line, which is including the analysis options from this linting package we created for this project. And that was also the main point, the main goal of it, because now lint rules can be configured globally in one place instead of individually per project. And as you can see, of course, on the right side, it is the analysis options of this lint package. If you take a look at the directory structure, it is also very simple. It consists of list of files, which corresponds to the lint rules you have implemented, and one file, applints.dart, that basically groups them all. Okay, so we stopped that code from being written as we speak. What do we do now?
Yeah, because it all looks nice on paper, all these rules, but making changes across all these repositories manually would be a nightmare, because when we added these updates, we saw popping up around 15,000 warnings in each repo. And remember, we have it, I don't know, 50? So really a challenge. That's where a codemod tool came to the rescue. And the codemod package makes it easy to write and run automated code modifications on the code base. So think of it as a smart find and replace feature in your IDE, just much smarter because it actually understands the Dart and Flutter syntax. So under the hood, it uses the analyzer packages API to parse the code and traverse the AST, which Kamil mentioned before. And the main goal is just to help you automate the whole process and just apply your changes using interactive CLI. So it's inspired by and based on Facebook's codemod library, so you might have heard of it before, but even if not, we'll show you it in action in just some minutes. So first, we need to add the package to the dependencies, and the documentation says we're going to use run interactive codemod method here. We pass the files, and those need updating, and a suggester, where we'll keep all the rules that we have to apply to run modification. So then the changes, when we run the command, they will appear in the CLI, and we can accept or reject them. And all of this stream of patches then will be saved to disk. So I know it might seem a bit abstract, so let's jump into a concrete example. So let's say we have many elevator pattern usages in our code base, like you see the one on the left.
and we want to replace them all with our add button from the design system. So as you can see, a simple find and replace wouldn't work here because the parameters don't match up. We have, for example, child with text and our button only accepts string. The same with style and color. And for simplicity, let's assume that the rest of the parameters just we can copy over without modifications. So now we'll write a codemod suggester that applies these transformations and runs it automatically, so it will be just replaced and the entire project in one go. So how do we write suggester? We have to write a class that extends AST visitor, and to find all elevated button usages, we'll override visit method invocation for our needs. And now I know it might seem a bit weird because elevated button is actually a constructor, not a method. But sometimes the analyzer doesn't recognize things the way we would expect, and this is one of those cases. But the good news is there are tons of visit methods that are available, and you can choose from depending on what you're looking for. So you've got visit constructor declaration, visit field declaration, visit function reference, and then many others. So you can always search through them and find the one that best suits your specific use case. And if the node is recognized as a elevated button, we're going to handle it arguments. So we have a switch here, and then we'll check for the parameters and extract the values from them. So as you can see, we have this on press, style, and child. And we'll take a closer look at the text extraction. So as you can see, we are currently on the nodes here. We again check for them if it's a method invocation and it's text. And then we have access to its arguments list. And if you remember, we just take the first one because it should be a raw string that we need to copy over to our new up button. And when we find this string, we return it. So finally, we put everything together into the new up button syntax with all the extracted arguments. And at the end, we just yield a patch at the location that was originally from the elevated button, so we're just replacing the code. So now let's run the codemod command and see the magic. So as you can see, the changes appear in the CLI, and for each finding the file, we can accept, reject, or quit the whole process. In the red, you can see the old syntax, and then in the green, the new up button. Maybe we should also run a Dart format, but I think that's all that we need. And if we don't want to review them individually, we can also accept everything at once, just using a shortcut. And there was just a quick demo how we can set up and use codemod. So what did we do in the project? So similar to app links package, we also created a separate repo to house all of our custom suggesters, and then we added it under the dev dependencies in all of our repositories. So now with a single command, we can run the codemod and fix all the issues at once in the entire code base. And when the new issues come up in the future, we can always create a new suggester and run it again. So you can see here we had some example with the padding migration suggesters, so with our design system one to just replace them because they had different syntax, and also some text widget migration. Instead of method, we used widget. But maybe one question is popping into your head. Why not use AI? Wouldn't that be less work? So, well, the short answer is we couldn't. Our security/privacy policies at bank don't allow it. And beyond that, which I know can be a bit controversial, AI just isn't as reliable as a deterministic tool. So we want to define exactly how it behaves here. There is no randomness, no place for hallucinations, and that's exactly what the codemod provides. And since we're laying out some big changes that we're fully responsible for, wanted something you can trust completely. So don't get me wrong, we do use AI on other projects. Also, we play around with it or try the feature also here. But in this case, we're sticking with controlled automation, and it gives us just more confidence. So, how did we ensure nothing broke during this massive refactoring efforts? So, we created a 6-layer safety net. And first, we have CI/CD validation, so we have running pipelines on every PR to check if we didn't break anything in other parts of the app. Second, we have solid test coverage, so we have units, widget, integration tests, and we set our threshold of the coverage at 80%. And this is also part of our pipeline checks. Third, of course, UI checks, mainly through golden tests. So it was really helpful with the design system changes. We could compare the screenshots to see if there were any inconsistencies. And our designer also would review these changes to make sure everything looked right. Next, we have our QA team that does regression testing. So every build gets well tested to ensure all of the journeys work perfectly fine before shipping anything to production. Next, we have code review, mainly from our tech leads and package maintainers, so people who really know the code base inside and out and have the domain knowledge, so they often caught some small but important issues. And finally, peer review by other LeanCoders, so they have big experience with refactoring and leans. So these reviews were pretty thorough. Sometimes we get like 100 comments under one single PR, but that was exactly what we needed to make sure that we maintain quality and we are safe.
Okay, so let's sum up all the helpful tips we said today. First, automation is a great ally when it comes to that scalability of large projects. And we're not talking only about complex tools like codemod, but also about simple Dart fix CLI command and search and replace function in your Visual Studio Code. They can be a great ally here, really. Custom links can help you to stop bad code from being written, and codemod can help you with both, because it can help you not only to do a broader cleanup, but also, like Aga mentioned, it will be still there, and whenever you came up with another idea of another refactoring, you can just write a new suggestor for the codemod and execute it anytime and apply all those changes easily in all of our projects. Also, you have to test everything and trust no one. You have to run unit, widget, golden tests, and ask your quality assurance to do regression tests. And if your quality assurance is busy or you don't have quality assurance, then you have to do it yourself, because at the end of the day, you are responsible for the code you write. And it's also good to involve original developers in the PR review process, because they know domain the best. They can actually tell if you broke anything. And seeing PRs like this, seeing diffs in PRs like this, gives them a direct bad versus good comparison, which is a great source of learning for them. Also, you have to document your changes and prepare guides for others. You know what you're doing, you know how to do it. These people don't. And what is even more important, they don't believe in the value of your changes. So along with these guides, you have to encourage adoption of these new guidelines by showing the concrete benefits they bring into the table. And you always have to measure the impact of your changes. We at LeanCode created a simple bash script which basically iterates over all projects and runs updated code analysis there, and generates a TXT report in which, as you can see, we can easily predict all impact over a new link through, so basically any other changes we'll have on the pipelines. And one last thing before we finish, what if I don't want to refactor anything? if you are lucky and you are in a rather early stage of project development, in 2 weeks, LeanCode is releasing our brand new guide called Migration to Flutter. It's made for teams who want to move their apps from native Xamarin, React Native, or basically any other framework to Flutter. And our team shares a step-by-step approach we use with our clients, real migration examples from big names like maybe Refactors Money, Slovak, Credit Agricole, and others. And if you scan this QR code, you can sign up to get it as soon as it's out. Whether you're just thinking about migration or have already started it, this guide will help you to do it faster. And we would like to thank you for your attention. And we would also like to ask you to reach out to us with your feedback, whether via LinkedIn, email, or even at the table today.
Yeah, so thank you, and do you have any questions?